In this video, we explore the quantum mechanics postulates. As we have mentioned before, quantum mechanics theory is the best theory that humans have developed. However, as drawback, we have also seen that there are some weird effects of the quantum world. In order to understand the origin of the weirdness of quantum mechanics, we need to study the postulates that describe it. The quantum mechanics postulates are the following. 1. The state of a quantum mechanical system is completely specified by a wave function. 2. The probability of finding the system at the position x is the square of the magnitude of the wave function. This is actually called the Born interpretation, after Max Born, who also won the Nobel Prize with Walther Bothe for their contribution to quantum mechanics. 3. Given two possible configurations of the quantum system with the wave functions, the system can also be in a superposition of these states, as follows. Now let's focus on each of the postulates in a deeper detail. 1. The state of a quantum mechanical system is completely specified by a wave function. In the cases we will analyze, we are going to consider a one-dimensional system, then the wave function is only dependent on x. On the other hand, it has to be understood that the wave function can have any shape, always it is continuous and single-valued. However, the most common wave functions are the sine, Gaussian, and wave packet. 2. The probability of finding the system at the position x is the square of the magnitude of the wave function. It is well known that the probability always ranges between 0 and 1. Also, we know that the magnitude square of a complex number, as the wave function, is simply the product of the number times its complex conjugate, then. Actually, these properties should be valid for all values of x. Then, when all the values of x are integrated, it should be accomplished that the probability is 1. Consequently, the magnitude square of the wave function. Let's check an example to see how this postulate works. Example 19. Determine the probability of finding a quantum system at position x' if the wave function is the following. Could you solve it? Answer? We can see that a graph of this wave function is the following. Then, calculating the probability by using the Born interpretation, we see that the magnitude square is simply resulting in a square magnitude of 1. Then, it is natural to ask, where is the particle located at? The answer could be confusing as the magnitude square is 1, for any position x. Then, the result means that the quantum system can be anywhere in the x-axis. This strange result appears from the fact that the wave function has a perfectly determined momentum. By knowing its wavelength, then, the information about the position is completely lost. Postulate 3. Given two possible configurations of the quantum system with the wave functions, the system can also be in a superposition of these states, as follows. In this case, we see that the probability of finding the quantum system in the superposition state, can be found by calculating the magnitude square of the wave function. Actually, by performing this calculation, we see that the probability is the following. It is clear that the first and second terms are simply the probabilities of finding the system either in the state 1 or state 2. On the other hand, we see that the two remaining terms are a mixture of states, that are usually called the interference terms, because they state the ability of the system of being in both states. Actually, this last statement is one of the crucial discoveries of quantum mechanics, as it allows the existence of a quantum system in two or more states simultaneously. However, when the quantum system is measured, its probability collapses to only one of the states. Actually, some of the weirdness of quantum mechanics comes from this postulate. We will explore more on this in next videos. Now, let's explore one of the consequences of the quantum superposition. Example 20. Quantum computing is a research area in which the quantum superposition is applied to allow faster calculations. For example, if we consider the classical bits, those used in modern computers, there are only two possible values for these bits. These are 1 and 0. Actually, in an electric device, these values could mean on and off positions of a switch. The combination of these two bits has allowed the ability to store and process any piece of information. A system with 2 bits of capacity can have 4 possible combinations of the bits. Meaning that out of those possibilities, there are no ways to store or process information. Moreover, let's suppose that a computer takes 1 second to perform each combination, then the whole set of combinations will take 4 seconds. Obviously, the values assigned are simply for comparison purposes. On the other hand, the so-called quantum bits. These bits are wave functions of a quantum system representing the on and off processes, and they can also store and process any piece of information, as the classical ones. On the other hand, as the qubits explode the superposition property, instead of having a limited number of combinations, as the classical bits, they can perform many more operations. But more importantly, all the combinations are made at the same time. These are the basic postulates. However, there are some textbooks where some other postulates appear, some of them related to the operators that describe the quantum system. In next videos, we will study the weird effects of quantum mechanics that we describe in a previous video. Stay tuned.